This thing sitting here in front of me is 100 years old. I doubt much of what I own now will be as functional in 100 years as this is now, and this will probably still work then. This is a comptometer. While technically an adding machine, I feel that term really sells it short. Yes, its main function is to add numbers to a running total, but that's almost a side effect of how it works as a key-driven machine. A more fitting name borrowing from a more modern term would be a real-time calculator. The comptometer is deceptively simple in how it works. You press the numbers and they're added to the visible register. But in this simplicity lies its power. So much so that Comptometer opened schools that taught lessons on how to use it. As it gained popularity, other institutions offered their own courses, such as this college that had 25 students join an after-hours, unaccredited course just because they wanted to learn more about how to use one of these. Which brings me to this video's sponsor. If there's a topic that you want to learn more about, you may want to check out Skillshare. Skillshare is an online learning community for creatives where millions come together to take the next step in their creative journey. Skillshare courses are formatted as video lessons that are broken up into segments, making it easy to spend as much or little time in your day on learning a new skill as you want. The available courses cover a number of different topics, like web development, graphic design, and video production. I've been trying to get into producing music for my videos more recently, and I've been working with my MT200 using SEQ24 as a software sequencer. I started watching this series on creating music with a sequencer for this segment, and I ended up watching all of it because it had a lot of good general information in it, even though I hadn't heard of this genre before. The first 500 of my subscribers to click the link in the description will get 2 free months of premium so you can explore your creativity. Now, back to the comptometer. Now, I want to give you a historical background of the comptometer, but I think it's important to first get an understanding of what makes the comptometer different compared to other adding machines. This machine is key-driven. That means the instant you release a key, it starts doing work. This is in contrast to devices of the time, like the Burroughs Portable, that acted on the numbers only when you pulled the crank. This is a subtle difference, but it is very significant in how you use the device. Performing addition is lightning fast, because you just have to key in the numbers you want to add. They are added together in the register at the bottom without you having to do anything else. The crank is instead used for when you are done and clears the register back to zeros, also called ciphers at this time. And even that is a quick and easy action that won't take you away from working too much. Now let's discuss its history. I mentioned in my recent video about the Burroughs Portable adding machine the mechanical revolution that was going on in the 1880s. The comptometer was the first new calculator design released during this period. While the arithmometer was first outright by decades, it was a very different style of machine made using much older production methods. And in the last decade of the 1800s, more adding machines were produced by new manufacturers than in the entire 50-year production run the arithmometer had up to that point. The comptometer was created by Dorr E. Felt. It was patented and produced in 1887. It was an evolution of an earlier key-driven adding machine patented by Thomas Hill in 1857. While a patent model was built for that unit, it was never commercially produced. The comptometer patent model moved the display to the front and sloped the keys to make them easier to use, like a typewriter. Felt worked with Robert Tarrant to set up a production facility, and the resulting company was named Felt and Tarrant Manufacturing Company. The comptometer was their first product. 2 years later, in 1889, they released an additional model, the Comptograph, a printing version of the comptometer. This still beat the Burroughs adding machine to market and was the first printing adding machine sold. And something really cool from a historical perspective, this one in this picture is literally the first one sold, and it is now in the care of the Smithsonian. The Comptograph was relatively short-lived though. After being split off in 1902 as a new company, Comptograph stopped production at the beginning of World War I. Other than that, there weren't many other major types of comptometers made. There was an option to get them equipped as a super totalizer that would allow you to add the contents of the main register to a second register, and there was an electric version of the comptometer that didn't sell particularly well, as the machine didn't really benefit from that in any way. Comptometers were more of a moving target, with successive models adding enhancements and continuing features from the old ones, but they stayed consistent in design. Eventually, the company behind the comptometer merged in the 1960s to form Sumlock Comptometer, but this was mostly to get the brand name, as the existing models were all dropped completely and replaced with new models from their new parent company, Bell Punch in the UK. This merger resulted in the first ever electronic calculator being released as a sum-lock comptometer, though it was designed completely by Bell Punch, being a comptometer in name only. Early on amongst the competition, the comptometer stood out. Being a key-driven machine meant it didn't need to waste time being cranked. Results were computed as quickly as the operator could input the numbers. Much of the early advertisement and documentation for the comptometer focused around this speed benefit. The skill of the operator being so important to this speed is what prompted Comptometer to open schools for training their users. There was real and long-lasting demand for those who could quickly operate a comptometer. I was able to find this US Department of Labor survey from 1971 that lists the salaries of comptometer operators. That's 84 years after it was introduced and during the time that electronic desktop calculators were becoming mainstream. Comptometers could still keep up though, something we'll take a look at later. Other companies took notice of this speed advantage, and the comptometer had clones starting to pop up very early. Burroughs notably and shamelessly completely cloned the comptometer down to the way the case was made. This brought on a suit by Felt and Tarrant, which they won. Burroughs was forced to change the external design of their calculator, but were still able to continue producing a comptometer competitor. As more clones popped up, Comptometer was put into a position of defending their trademark name to prevent it from becoming genericized, because everyone ended up calling all key-driven calculators comptometers. Alright, let's take a closer look at the comptometer I have here. This is a Model H, which would have been made sometime in the 1920s. The Model H carried over features from previous models. Duplex keys, which meant it could accept multiple keys being pressed at once, the controlled key for error correcting, and the carryover levers, both of which we'll take a closer look at in a bit. And one final existing feature would be the decimal indicators on the front, but these are really only useful for division, and even then you could work without them. The main new feature the Model H brought to the table would be its clear signal ready indicators. These gave you 3 different forms of feedback to ensure the register was fully cleared when you pulled the crank. Visually, the zeros are off center. Audibly, the first key press after clearing produced a ringing by striking a bell, and tactually by requiring more force on the first key press, though I find this effect hard to feel on the keys towards the front and very pronounced at the back. The touch and bell were the more important additions here though, because comptometer operators were actually trained to use the machine by touch only, much like how you should learn to type on a keyboard without looking at it. The keyboard lacks a definitive home row, but the keys do alternate between flat and concave tops to give you a tactile feel of where you are. Additionally, you'd be trained to move your hands as little as possible. This was achieved by limiting yourself to just the 1 through 5 keys. It's clear whoever was using my comptometer originally was a well-trained operator, because the 1 through 5 rows are significantly more worn than the 6 through 9 rows are. It was faster to do 2 or 3 keystrokes to add the smaller numbers up to the larger ones than it was to move your hands and rehome. Now, looking at the keys, you may be wondering why there are 2 sets of digits. The smaller set of numbers are called co-digits, and they are how you do subtraction on the comptometer, or really any calculator. Those numbers represent the 9's complement of the digits the keys are for. The principle is, if you add the 9's complement of a number you want to subtract, then ignore any carryover and add 1, you will get the result of a subtraction. So if we want to subtract 63 from 88, first we will enter 88. Then you will subtract 63 by pressing the small numbers. From here, we could either ignore or remove the 1 carried over and add 1 to our result, and we get the correct answer, 25. The efficient way to do this on a comptometer is to subtract 1 less than the number you want, 62 in this case, and use one of the carryover prevention levers to prevent the extra 1 from showing up to begin with. I want to explain why you have to add or minus 1 so you can understand why you have to do it and help explain 9's complement subtraction overall. Forget about how we're getting the end result we want and just imagine the subtraction process as adding a negative number. On the comptometer, there is no way to input a negative number, so instead we want to work with a positive number. If we add 99 to the 2-digit number we want to subtract, it is guaranteed not to be negative anymore. At this point, it would help to think of the number as now being overloaded with 99 in some way that needs to be reversed later. Now that both numbers are positive, we can proceed as if we were adding 2 standard positive numbers, but the result takes on the overloaded state. When we do an overloaded addition, we get a much larger number than our intended result for a subtraction, but it is visually similar. The most significant digit is just off by 1, and we can drop that. But when we try to remove that, we are effectively subtracting 100 from our final number. This also removes the overloaded state we did earlier, but we're now underloaded by 1. So if we add that 1 back, we now have the correct answer. Using 9's complement values on the keys is just like adding a 9 to a negative number, so anytime you need to subtract a 9 digit, you can skip it. When you take 1 out of the number you want to subtract, you're getting that extra underloaded 1 out of the way in the beginning of the problem. Then you are free to ignore the added value in the most significant digit by holding the carryover prevention lever. There's only one other trick to 9's complement subtraction you need to remember. If you are subtracting a number with fewer digits than your starting number, you need to borrow a 0 with the 9 keys to match the number of digits. If you don't, your most significant digit will be 1 greater than it should be. Borrowing a 0 properly rolls over the digit counter so the result you want appears in the register. Note that you do not need to borrow zeros for least significant zeros, and you minus 1 from the first digit that has a non-zero value. So if you're subtracting 50 from 100, you would have to subtract with the keys 0, 4, and nothing to get the correct value. Whew, okay, that's a lot of 9's complement info, but you don't need to remember all that when you're doing subtraction. You just need to hold the carry, subtract the number you want, minus 1, with the small keys, and it goes by very quickly when you're used to it. Speaking of very quickly, let's move on to multiplication, because the Comptometer is incredibly quick at that. The Burroughs machine had a repeat key, so you could hold down the keys you wanted to multiply while you pulled the crank. The Comptometer doesn't need that, since you just press the keys you want immediately. So if you want to do 12 times 12, you just press 12 in the first column twice, move over 1 digit, and press it again. That's it. You could do this as fast as you wanted, but since you can change which keys you press with every keystroke, you can use another method. Here is 12 times 12 again, that way. This method works with rows that lets you keep your fingers together, saving you time on placing individual fingers. Let's take a look at an example of this from a book on how to use the Comptometer. You need to pay attention to 3 things about the number when you're multiplying it. What number you're multiplying by is the row you place your fingers on. The columns your fingers are on will match the number of digits in the number you are multiplying, and the number of times you press each key is the same as the digits you are multiplying. This is a little complicated to wrap your head around at first, but as you practice it, it begins to make sense, and I could easily see how this method would be faster, especially for those who are trained on the 1 through 5 rows, since you could easily adapt this method there by combining rows. Now, pressing multiple keys at once isn't the easiest thing, especially during rapid operations like multiplication. Sometimes you may not press the keys down fully. The register digits have gears on them and are moved by a toothed bar that meshes with the gear attached. If you didn't press the key all the way down, the bar may not move the gear enough and add the wrong number. The Comptometer had a feature added to detect this though, the controlled key. When a mistake is made, this key pops up. The entire keyboard locks except the column that was mispressed. You can clear this locked state in one of 2 ways. You can either repress the key in the unlock row and then press the controlled key, or pull the crank and start all over again. It is somewhat unsettling to have the keyboard just lock up when you're using it, so I would say this feature does its job well. It can be easy to correct, but you don't always know which number you were trying to type, so I would just pull the crank and start again. Now it's finally time to cover division. This is always the most complicated thing you can do on an adding machine, and the Comptometer is no exception, but for a different reason. First off, the usual pen and paper method of adding machine division works perfectly fine, and is actually very quick. You key in the number you want to divide on the left, and subtract the number you are dividing by until you can't anymore, and write down the number of keystrokes. You do this just like before using 9's complement. Then you move on to the next digit until you've worked through the entire number. But the Comptometer has another weird trick that will put the result in the register as you compute it, but the manual doesn't explicitly tell you how this works. I'm not sure if this was to try and prevent competition from copying it, or if they just didn't want to take the time to explain it, but it's a quite clever use of the 9's complement rules. Let's start off with a simple bit of division. 36 divided by 12. This trick has you do subtraction, but not prevent the carryover. If we do normal division like this, every time we subtract, we get a carry. This will happen as long as the number we are dividing is greater or equal to the number we are dividing by, because the 9's complement numbers will make it carry 1. After 3 subtractions of 12, the number we are dividing is 0, and it was carried 3 times, which is our answer. The number to the left effectively becomes a stroke counter like you normally do in your head for the pen and paper method, but it gets weirder. Let's do 64 divided by 8. Because there are fewer digits in the number we are dividing by, we need to borrow a 0, and we can't subtract 8 from 6, so we will start on the 4 column. After running through it, it worked here as well, producing 8 as the answer. But the real trick to the Comptometer division is that you don't need to borrow a 0. If you do the same motions as if you were borrowing the 0, the result just ends up one column further to the right. The difference is, you can't see when you fully subtracted your number if you don't borrow the 0. But part of the trick is that you can always subtract at least the number of times that is shown in the digit to the left of where you are subtracting. You are trying to catch up to the number of key presses in that digit, which means that if that number increases, you need to keep going to match it. When you've caught up, it is the same as having made the most significant digit 0 in the number you are dividing. You repeat this process on the next keys to the right in the same way. Catch up the key presses and then subtract until you can't. Eventually, this will put the correct answer in the display. A larger example would be 365 divided by 7 to get the number of weeks in a year. You can see I have to keep moving to the right and catching up the key presses, but eventually the correct answer of around 52.14 is found and displayed. This takes some focus, but overall it works pretty well. This method is only feasible on a device where you can watch the register change and is made much quicker by not needing to pull a crank. The manual goes on after this to show how you can mix this with the row-based input like multiplication, but frankly, that would add way too much more effort to this process, and I'm just here to have some fun. This method is already plenty fast. And if you really want to delve into this, the book I've been referencing here will teach you how to work with fractions, calculate interest, and even find square roots, but I think we've covered enough for now. We have one last major topic I think is worth talking about. Now that you've seen how all the operations are performed, you have an idea of how they work. This device may seem antiquated today, but how does it actually stack up against an electronic calculator? Its speed was a big selling point, so let's find out how quick it was. This is my Sony Sobox ICC 1600 that was released about the same time as that labor survey I mentioned earlier. I'm going to run through addition, subtraction, multiplication, and division simultaneously so you can see how they stack up. And the Comptometer is at worst only as fast as the calculator, and much faster for simpler operations. This will depend on what you're doing, and I did pick numbers that are easy to work with. Complex division will favor the electronic calculator for longer repeated operations, but the Comptometer has its own advantages. If you were doing simple additive accounting, the Comptometer's ability to have entire numbers keyed in at once makes it faster than the processing ability of the 10-key limited calculator. And I think that is finally everything I can talk about for the Comptometer. Being totally honest, I didn't fully understand what I was getting into when I bought this thing. I paid much more at an antique store than I normally would have liked, but I could sense there was something special to this, and I have absolutely no regrets about it. This is easily tied for my favorite calculator in my collection now with the Sobox. It is amazingly capable for being so simple, and it just comes down to a few clever features. And learning how to use it has made me relearn some bits of math in new ways that I really like. I don't think I'm ever likely going to get my hands on an original arithmometer, and definitely not one of the 20 Pascalines out there, so the Comptometer is realistically the earliest example of a calculating device I can get, and it in no way disappoints. I hope you enjoyed this look at a Comptometer, and if you want to support the channel, I am on Patreon, but for now, that's it. I'll see you later. Actually, that's not it. There are a few more things I couldn't fit in that are interesting. The yellow digits are like that to match the colored keys. The case is copper-plated but coated and even lacquered on the front plate. The inside is amazingly dense, like it is woven out of metal. The case is covered in cork to silence it, and rolling over the digits is awesome.